So this is the day everybody's been waiting for. Now we get to combine what we know about circles with what we know about proofs. All right, so some theorems that you need to be aware of regarding arcs and angles are all on this page in your notes. Now, this looks a little intimidating and a little overwhelming, but if you connect it to what you already know about circles, really this is just putting all those ideas that we've been developing regarding circles into sentence form so that we can use them for proofs. For instance, you know that anytime two central angles are congruent, their arcs have to be congruent as well. The degree measure of the arc is congruent or is equal to the degree measure of that central angle. So if the two central angles are congruent, the two arcs will have to be as well. And conversely, anytime you have a pair of congruent arcs, like you see marked in the diagram, their central angles have to be congruent as well. One that you might not have seen before is that anytime you have a pair of congruent central angles, they'll have congruent chords. So the green central angles that you see in the picture marked congruent imply that chord AB and chord CD also have to be congruent. And that works backwards as well. Anytime you have the congruent chords, the central angles that accompany those chords or go along with those chords have to be congruent as well. The third one says anytime you have congruent arcs, like in the picture, they've marked arc CD congruent to AB, then the chords that are determined by those arcs have to be congruent as well. So in this case, chord CD would be congruent to chord AB. The next one there's no picture for, so we're going to draw a little sketch in there. It says anytime you have congruent inscribed angles, so let me draw a pair of congruent inscribed angles. There's a pair of congruent inscribed angles. This says their arcs must be congruent as well. Well, again, the measure of the inscribed angle is going to be half that of the arc. So if the two angles are going to have to be congruent, double that, the two arcs have to be congruent as well. And conversely, anytime you know these two arcs are the same, we know that the inscribed angles that go along with those arcs must be identical as well. The next one we've seen before, but it bears repeating again. It says inscribed angles that intercept the same arc are congruent. Now, if I look at this picture, the arc that goes along with inscribed angle A is that arc that I just made green on the screen. Angle A has degree measure half that of the green arc because it's an inscribed angle. Angle C has degree measure half that of the green arc. And therefore, angle A and angle C must be congruent. Likewise, if I take a look at the purple arc, the inscribed angles that intercept the purple arc are angle D and angle B. And because they are two inscribed angles that intercept the same arc, they have to be congruent. The next one we've seen and used in problem solving, all radii of the same circle have to be congruent. So since segment OA is a radius, OB is a radius, OC is a radius, and OD is a radius, we know that all four of those segments must be congruent. And lastly, an angle inscribed at a semicircle is a right angle. We've talked about this one in class also. That semicircle has degree measure equal to 180 degrees. The measure of the inscribed angle, in this case, angle B, has to be equal to half that 180 degrees, making the degree measure of that angle 90, and therefore making that angle a right angle. All right, so let's go write some proofs together that involve the use of these theorems. In number one, we're given that arc AB is congruent to arc CD. I almost like to mark these with colors or highlighters more than I like to mark them with slashes. So I'm going to indicate through use of color on my paper that those two arcs are the same. And I've said over and over and over this year, I would strongly encourage you to get a set of highlighters. If you haven't yet done that, I would again very strongly urge you to put a set of highlighters in your hands because they are going to be helpful. We're trying to show that these two angles are congruent. So not immediately, but pretty quickly, I think if I could show a pair of congruent triangles, I could use CPCTC to conclude that a pair of corresponding angles have to be congruent. So my goal or my mission is going to be to get a triangle that contains angle ABC congruent to a triangle that contains angle DCB. And in looking at this picture, I notice that an inscribed angle for the green arc AB is angle ACB. That's going to be a congruent to an inscribed angle for green arc DC. So those two inscribed angles have to be the same. Segment BC is the same in both triangles, so a little reflexive property will get that congruent to itself. And if I look further at the question, it would be really, really nice if I knew that this point of intersection was the center of my circle, but I'm not told that anywhere, so I cannot draw or make that conclusion. I do know, if I take a look at the picture, that there are two angles that both intercept the purple arc. The two inscribed angles that intercept the purple arc are angle A up here at the top and angle D up here at the top. And they have to be congruent to each other. So in looking at this picture, I'm seeing angle, angle, side in the first triangle, angle, angle, side in the second triangle. Because those triangles are overlapping, it might help you to envision or see the picture better if you draw the two triangles separately. So again, we have angle ACB congruent to angle DBC. We have BC congruent to itself. And we have angles A and D congruent. So again, that's a little bit of angle, angle, side. So now that I know what I'm going to write, and only now that I know what I'm going to write, do I sit down and begin my proof. You might have also seen side AB congruent to side DC because they're chords that have congruent arcs. And anytime you have the congruent arcs, the chords are congruent as well. So that would give you a little angle, angle, side action also. So there's a lot of different ways that you can see and write this proof. I'm going to go ahead and start out by talking about those two congruent chords. I'm sorry, the two congruent arcs. And those two congruent arcs actually gave me quite a lot. They gave me that chord AB was congruent to chord DC. And that's because congruent arcs, so I'm going to talk about the congruent arcs up here first of all, and tie their relationship to the congruent chords. Have congruent chords. And likewise, that also gave me, I'm going to number them angles 1 and 2. And again, I'm going to start by talking about what these congruent arcs gave me. So congruent arcs, and then I can't just say congruent angles, I have to say congruent inscribed angles. So make sure that you're familiar with and using that vocabulary. So there's my pair of sides, there's a pair of angles. Going back to the picture, the other pair of angles that I wanted to make mention of were angles A and D. And I knew they were congruent because they both intercepted the same purple arc. Angle A intercepted arc BC, as did angle D. So inscribed angles, and again, I'm making very good use of my vocabulary. They're inscribed angles that intercept the same arc are congruent. So at this point, I've talked about a pair of congruent sides. I've talked about two pairs of congruent angles. Now I'm all set to go ahead and conclude that those triangles must be congruent. So triangle ACB must be congruent to triangle DCB, and that's by angle, angle, side. And once the triangles are congruent, it follows that all their corresponding parts must be congruent. So angles ACB and DCB must be congruent by CPCTC. So there's a nice little proof that combines your new knowledge about circles with your old knowledge about triangles all together in one proof. All right, let's go ahead and take a look at number 2. Number 2 says arc AC is congruent to arc AD. So I might immediately, as soon as I see those congruent arcs, I might go look and see, do they have any inscribed angles? Well, the inscribed angle for arc AC is angle D. The inscribed angle for arc AD is angle C. So that's going to make those two angles congruent. BE is perpendicular to AC, so I'm going to go find those and draw the right angles in there. BF is perpendicular to AD. And B is the midpoint of segment CD. And we're trying to prove or to show that segment EB, so that guy right there, is congruent to segment FB. So I'm hoping you're seeing the triangles that we're going to prove congruent by angle, angle, side, similar to in the first example. Once the triangles are congruent, the corresponding sides must be congruent as well. So this one I think I'll write in statement reason form. So I'm going to start out by talking about or discussing those congruent arcs. And it was those congruent arcs that led me to the congruent inscribed angles. So angles C and D are congruent. So again, those congruent arcs have congruent inscribed angles. And I'll cite statement 1 since that's where I had the congruent arcs. The next thing that I looked at were those perpendicular lines. And those perpendicular lines are what gave me the right angles. So I'm going to say angle CEB. I don't just want to call it angle E because that would be ambiguous as to which angle E I was talking about, is congruent to angle DFB. Oh, I need to back up. I need to state that they're right angles before I can draw the conclusion that they're congruent. So angle CEB, so let me back up and make that adjustment. And angle DFB are right angles. And that's because the perpendicular lines in statement 3 cause those angles to be right angles. So perpendicular lines form right angles. And I'm going to cite statement 3 because that's where I had those perpendicular lines. And now I'm all set up to go ahead and state that those angles are congruent. All right, and at this point, I've talked about one pair of congruent angles, two pair of congruent angles. I still need to get my pair of congruent sides in there. So I'm going to go ahead and use that midpoint. D is the midpoint of segment CB. And that gave me segment CB congruent to segment BD. And I'll go ahead and cite statement 6 because that's where I had the midpoint. So now I've discussed my two pairs of congruent angles and my pair of congruent sides. Now I'm all set up nicely to state that the triangles are congruent. And when I do this, I'm going to make sure that I match up all their corresponding parts. And then lastly, I can draw the conclusion that all of their corresponding parts, including sides EB and FB, need to be congruent as well. And that's CPCTC, using the congruent triangles in statement 8. All right, so yes, I did run long with the video today, but notice there's no check your understanding or problems for you to try on your own. We'll work on writing through some of those proofs when you come to class. Now that said, you might want to get out ahead of the curve and jump on those right now and see if there are ones that you can do or ones that you're really truly stumped on and need my help with when you come back to class.